So, I'm sure many of you in Year 9 have seen the equation y equals ax squared plus bx plus c, and that it has plotted a parabola. In Year 10, you may have seen the equation to solve for the roots, which is x equals negative b plus root b squared minus 4ac all over 2a. And you may have thought that that was very complex and been confused about the derivation behind it. You're not wrong, it is very complex, but I'm here to explain the derivation. So you're given a parabola on a Cartesian plane. Before you can find the roots, you must first find the y-intercept, which will be c, the y-coordinate c, because ax squared and bx both contain the variable x, which equals 0. You must then find the y-mirror, which has the same y-coordinate, c, as the y-intercept, but x is not 0. Ax squared plus bx must still equal 0 though, or in other words, ax squared must equal negative bx, ax equals negative b, x equals negative b over a. Then we want to find the turning point. So x of the turning point is half the x coordinate of the y mirror, because it's halfway between the y-intercept and the y mirror. So 2a. When we want to find the y coordinate of the turning point, we must sub this back into the original equation. So a times neg b over 2a squared plus b times neg b over 2a plus c equals a times b squared over 4a squared plus negative b squared over 2a plus c. The a multiplying with the denominator of that cancels out the a squared, so b squared over 4a plus negative b squared over 2a plus c. Since the second term in this expression has a denominator half as much as the first term and the same numerator, well, it will be the same numerator if we express it like this. So that means that this is half as much as that, half as much as this, which will result in negative b squared over 4a plus c. We know that because half of the negative this, because it's like 1 times that minus 2 times that, which gives us the coordinates of the turning point x and y as negative b over 2a and negative b squared over 4a plus c. We want to know the change in x from the turning point with a given change in y. So we know that the change in y equals a times the change in x squared. Therefore, the change in x equals the square root of the change in y divided by a. The change in y from the turning point is negative b squared over 4a plus c, so we'll divide that by a. Oh, that's the y. Here is the y of the turning point, but in order to change in y, you need to y minus that over a. Here we have a problem though, because with a positive a, the parabola will be like this, and so the y of the turning point minus the y of somewhere else on the graph will give somewhere down here a y somewhere down here where there's no x coordinate of it. So we therefore need to negate this so that the y coordinate is up here, and we'll have two solutions, which we do that by going simplified to b squared over 4a minus c plus y over positive a. Quite often you'd try to balance the equation so that y is 0. So this can be omitted, but we may as well leave it in. When you learn the formula in school, it will probably be omitted though. So anyway, this part is what teachers call the discriminant. So that's the change in y. So the change in x, that's the change in x. So the change in x is called the discriminant. But we want to know the actual x value, not just the change in x. So that will be the x coordinate of the turning point plus or minus the discriminant. The discriminant equation that I had can be simplified though. I will omit the y term. You can put it in if you want, but if you do, I suggest leaving it the way it was before. But this can be simplified to, I'll divide by a. This can be simplified to b squared over 4a squared, because we're putting the a up there, minus c over a, or we can times the top and the bottom both by 4a if we want. So that would be square root of b squared minus 4ac divided by 4a squared. This is a square number, so it can come outside the radical, leaving a discriminant of b squared minus 4a. So leaving a discriminant of b squared minus 4ac over 2a outside the radical. And therefore, so x, we said before, is negative b over 2a plus or minus this. So plus or minus root b squared minus 4ac 2a, or much neater, b squared plus or minus, not b squared, negative b plus or minus b squared minus 4ac over 2a. And that is the equation that you'll learn at school. Now what I've done here is So of course I've left the y term in. Wait, I'll make that black so it's visible. I've left the y term in. I'll highlight it actually. I've left the y term in. So minus 4ac, and we had a positive y before. I couldn't get the plus or minus sign, so I put one with the minus and one with the plus. But then the conventional parabola formula. And you can't see because these two half parabolas perfectly cover the full parabola. And as you can see in the play of the video, when I change the values, it still perfectly covers the conventional parabola, so you can see that it works all the time. Anyway, so yeah, that is how the quadratic roots formula was derived. And I did happen to work this out myself, by the way, before I'd learnt the formula. So yeah, just good to know why your teachers teach you what they do.